going to talk about some polynomial functions. So first we need a definition. A polynomial is a monomial or a sum of monomials. So it just means that it's some type of an expression, or it could be an equation that is just the sum of monomials. And what it has to have are only positive whole number exponents on all of the variables. So in our examples below, we want to circle all of the polynomials. So you're going to circle all that on all of the variables, you have positive and whole number exponents. So if it doesn't have a variable, like -3, that's fine. But on your variable, it has to have a positive whole number exponent. So 2x squared minus 3 is a polynomial. 4x to the 0.5 plus 1, that is not, because this exponent is not a positive whole number. 3x to the 4th minus 5x to the 5th plus x is a polynomial. Because remember, when it's x to the 1st, and 1 is a positive whole number, which means just x is a polynomial. And our last one is not, because we have negative 2x to the negative 4th plus 3x. That negative 4 is not positive and whole. Polynomials cannot have any type of a root in them. So like the square root of x, it's not a polynomial. Has to be positive whole number exponents, no roots on them. We can classify a polynomial. So a monomial is if there is exactly one term, like 7n, like 15. Doesn't have to have a variable. 15 is a monomial. 6p to the 4th. Those are all single term polynomials. Those are all monomials. 2 terms are binomials. So that would be like 3x plus 1. 2g to the 7th minus 8f to the 4th. 2 terms, 1, 2, 1, 2. A 3 term is a trinomial. 5y to the 4th minus 2y to the 7th plus 8. Trinomial has 3 terms. Anything longer than 3 terms, we don't give it any special name, super complicated names. We are not going to worry about those. So a polynomial that has 1 term is more specifically a monomial. A polynomial with 2 terms is more specifically a binomial. And a polynomial with 3 terms is more specifically a trinomial. Anything longer than that, we're just going to keep calling it a polynomial. We're not going to give it a special name. Knowing that all of these are polynomials, they are also just more specifically a monomial, binomial, or trinomial. So if I ask you, is this a polynomial? Yes. But then if I say classify it more specifically, then you say trinomial. Next, let's talk about standard form. Standard form is when your terms are arranged by degree, exponent, in descending numerical order. So when you have an equation, the y part, you just leave it there. Y equals. Then we're going to focus on all of your other terms and make sure they are in order from largest to smallest. 2, 1, remember there's 1 here, and none. Your constant, if there is one, should always go last. 7, 4, 1, none. This is not in standard form. Let's fix this one. So y equals is going to stay y equals. Largest exponent would be this 5. And it's positive, so 2x to the 5th. I use that one. Next largest would be this 4, which is a plus 9x to the 4th. Then would be this 2, which is minus 7x squared. And then your x, so plus 3x. And then that's a positive 3, so put a plus 3. If it had a negative in front, you'd put a minus 3. Now that is in standard form. There were 1, 2, 3, 4, 5 terms. Make sure there's 1, 2, 3, 4, 5 terms. There you go. All right, so this was classifying based on the number of terms. Just count how many terms there are. But there's also a way to classify by the degree. The degree of a polynomial is the biggest exponent. So 2, 7, 5. We are going to classify these based on exponents 1 through 5. Anything bigger than that, we won't classify based on degree. So a linear is if it has a degree of 1. So 3x plus 1 is linear. This is also a binomial, right? 2 terms. So you can classify this in 2 ways. By the number of terms, binomial, and by the exponent, the degree, 1, linear. If your largest degree is is 2, it's a quadratic. 4x squared plus 7. This is a quadratic binomial, 2 terms. If your degree is 3, that makes it cubic. So like 4p to the third is cubic because of this cube on it. And it's also 1 term, so it's also a monomial. If its largest exponent is 4, that makes it quartic. So like 5g to the 4th minus 7g to the 3rd plus 8g is quartic, because the largest exponent is 4, is also a 1, 2, 3 trinomial. And quintic is if it has a largest degree of 5, like 6p to the 5th is now quintic. Also, this example is a monomial because it has 1 term. So there are 2 ways to classify polynomials: by the number of terms, monomial, binomial, trinomial. The number of terms are things with nomial in the name, sometimes helpful. Whereas your degree, your exponent, or your linear, quadratic, cubic, you should know those. Linear and quadratic, we've definitely talked about. A cubic has a cube. And then quartic and quintic. So in your examples on the back, we're going to write our function in standard form, if needed. And then we're going to classify it by the number of terms and the degree. So standard form, y equals. I need my constant last, so I just need to flip those and put 3x plus 2. So I'm going to classify this now by the terms. There are 1, 2 terms, makes that a binomial. And the degree, there's no exponent on this x, which makes it 1. That's a linear. Right? You know that. Y equals 3x plus 2. You know that that's linear. In our next example, we already are in standard form, the 5th and then the 1 and then the none, already in order. So now let's just classify by the terms and the degree. There are 1, 2, 3 terms, makes that a trinomial. And your largest exponent is 5, makes that quintic. Example 3, already in order, because there's not an order. How many terms are there? There are 1, that makes that a monomial. And the degree, it has a 2, you know that one, that's quadratic. And your last example is not in order because we have 2 and then 4, so we need to switch those and put negative x to the 4th, and then positive, so plus 4x squared. And then you can classify. There are 2 terms, makes that a binomial. And your degree is 4, makes that quartic. Okay. Linear and quadratic and cubic, like I said, should be pretty easy to remember those. We've talked about those before. You've talked about them in Algebra 1 and again in Algebra 2. Quartic, you kind of think of like a quarter, and 4 quarters make $1. And then quintic is the other one. Quintic is 5. All right. Let's get into talking about the graphs. So the end behavior, which we've talked about before with quadratics. The end behavior deals with or comes from the degree of your polynomial. That degree is going to affect the shape of the graph, and the maximum number of turning points, so how many times it changes direction. It's also going to affect your end behavior, which are the directions your graph points on the farthest left and the farthest right. Your end behavior is going to be pointing either up or down. We're going to look at the ends left to right to see what's happening left, is it going up or down, and what's happening right, is it going up or down. It will also be affected by the a value, which is your leading coefficient. So the a value here is 7. The a value here is -8. The difference in your a value is whether the a value is positive or negative. So a positive 7 is going to do something different than a -8. So the number of turning points, the a value does not affect. The number of turning points comes from, is it linear, quadratic, cubic, quartic, or quintic? A linear graph has no turning points. Because a linear graph, and we are dealing with if the a value is greater than 0, so if that leading number here is positive, you know a linear makes a line. If it's positive, it's going to be going in an upward direction. See how there's no turning points there. So the end behavior, as I go to the left, it is going down. So we've talked about end behavior before. It is the limit, which is abbreviated LIM. First, you're going to talk about as it goes to the left, which is as x goes to -infinity. Well, as you go left, it's going down, so that equals -infinity. We also need to talk about what happens as it goes to the right. So the limit as x goes to +infinity, as we go to the right, it is going up. Okay, quadratics have at most one turning point. These are all at most. So at most 0, obviously 0. Can't have negative turning points. At most 1, we'll keep going from there. Quadratic, if the a value is positive, we know quadratics make a U. If it's positive, it's going to open in an upward direction. So see how there's 1, 2? So there's one turning point. It's right here. This is that turning point. It changes from going down to going up. So the end behavior for this, as I go to the left, I'm going up, and as I go to the right, I'm going up. So this one, the limit as x goes to -infinity is +infinity, and as the limit goes to +infinity, it also equals +infinity, because as I go to the left, I'm going up, and as I go to the right, I'm going up. Okay, cubic have at most 2 turning points. You see a pattern here? Keeping in mind your degree of linear is 1 and has 0 turning points. Your degree of quadratic is 2 and has 1 turning point. Your degree of cubic is 3 and has 2 turning points. So this quartic that has a degree of 4, that is going to have 3 turning points. And your quintic, which is 5, has 4 turning points. Now, we are dealing with the a value being positive. So your graph of a cubic would look something like this, where it's going to go in this upward direction, and see how there's 2 turning points. I'm going up, down, up. It is going in a rising direction because our a value is greater than 0. So these limits are not the same. Left is down, right is up. Okay, quartic. 3 turning points. I want my a value to be greater than 0, so that's going to look something like this, where I have 1, 2, 3 turning points. And notice how both ends are going up. So this is similar to quadratic, where both of them are going to +infinity. And then your quintic has 4 turning points, and if I want it to be positive, it should go in a rising direction. So there are 1, 2, 3, 4 turning points. And your ends go in opposite directions. linear, cubic, and quintic are 1, 3, 5. Those are your odd degrees. I starred them because they're the same. Your graphs are different, but the end behavior is the same. And then your even degrees, your quadratic of 2 and your quartic of 4, are different than your odd, but the same from each other. So your graphs all depend on your degree, but your end behavior depends on if it's odd, they're different, or if they're even, they're the same. Okay, let's now talk about what if the a value is less than 0. So if the a value is less than 0, we have a negative leading coefficient. That is not going to affect your number of turning points. The number of turning points come from the degree. So this is still 0, 1, 2, 3, and 4. It's going to affect your end behavior and your graph because now if your a value is 0, instead of a linear graph increasing, my linear graph is going to decrease. Instead of my quadratic pointing up, it's going to point down. Instead of my cubic rising, my cubic is going to lower. Instead of my quartic pointing up, my quartic is going to point down. And instead of my quintic rising, it's going to lower. So there's still 0, 1, 2, 3, and 4 turning points. They just go in opposite directions because that a value points you down. So the end behavior, essentially, just like all switches, your linear, cubic, and quintic will all match. This time, as I look to the left, I'm rising, so I'm going to positive infinity. And as I look to the right, I'm lowering, going to negative infinity. 1, 3, and 5 all match, right? As you go to the left, it's rising. Same thing here as I go to the left. Get a little negative in there. Got that negative sign. And there's a negative here. As I go to the left, I am rising. And as I go to the right, I am lowering. And your quadratic and quartic still are going to have the same as you go left and right. But this time, instead of going up, they're both going down. So as you go left, you are going down. And as I go left, I'm going down. And as I go right, I'm also going down. All right. So if I ask you to do like this whole thing, I would start with number of turning points because that's relatively easy. You take the degree and subtract 1, right? The degree is 5. That means there's 4 turning points. The degree is 2. That means there's 1 turning point. Then I would do the graph, which is why I did that in that order. I know, should have did it differently on your notes. I should have put this and then this in your table. But I would do your graph next, paying attention to your a value, whether it's positive or negative. So your degree tells you your shape. Your a value tells you up or down. Your degree tells you your shape. The a tells you up or down. Degree tells you your shape, then rising up or rising down, so on and so forth. All right. Then I would do your end behavior because once you have a picture, it's a lot easier to say, well, left, what's happening, right, what's happening, left, what's happening, right, what's happening, so on and so forth. All right. You are not going to be allowed to use a calculator during this knowledge check because the point is for you to make sure you know what's happening without technology. So I would not rely on your calculator during your practice.